Good morning. Hello, people that watch my videos, whoever you are. Fewer and fewer, but whatever. Oh. So, today I'm going to address this because this has come up, and I guess this is like this whole quantum gravity notion because quantum mechanics is not a fully integrated system. It sits apart from general relativity, and they need to be integrated, but really, I don't understand why they're separate. So the topic of today is gravity creates charge. And I don't want to get into a super like plasma universe place with this necessarily, because I don't think you have to. But let's just start. Okay, here is some flat space. Very little is happening here. Let's pretend there's nothing happening. These perturbations are so small that they don't actually manifest. Okay? Ooh. There's some flat space. So let's pretend that we could create some mass. Let's create some mass. We're going to create a little mass unit. Okay, here's a mass unit. Boop, boop. Which, in my model is a photon that is trapped over its own gravity, a 2 pi Planck length photon trapped over its own gravity that sits there spinning. And because it's spinning, just using classical mechanics, we say, well, there's energy in a membrane, but energy is energy, and energy is where mass comes from, and this is how it comes. So the energy curves space enough so that they basically, like this ball is rolling in its own orbit. Boop. This energy over here is enough to keep this energy curved enough trapped over the orbit. Boop. Okay, and then the classical angular momentum is velocity squared. This is going at c, so now we have c squared. Mass is equal to energy spread over a spherical surface, because this is actually going, in all directions simultaneously, giving spherical angular momentum. Mass is energy trapped over its own thing going at the speed of light squared. Okay. So let's just drop one mass unit by itself, a chargeless mass unit, into space. Well, this mass unit, of course, is going to bend space-time. Like that. And what do we find? Let's just imagine that space was covered in these little spikes or something, just orientations. And what do we find here? That because of the mass's effect on space-time, here we have all this convergence. These are pointing at each other. It's like it's extra dense. And over here at the edges of the curve, this is wider than parallel. This is divergence. So this curve creates both divergence and convergence. Oh, and there's the mass unit. And how would this field come out? It would come out like this, right? Because this is how it's affecting space. Divergence. Convergence. Positive, negative. Mass curves space-time, and like Casimir effect, because, or like more detailed, I'm pretty sure Stephen Wolfram did a paper that was actually like sort of like a more geometric analysis of how curving space-time or curving a cavity creates charge distributions and what different shapes you can create and what simple geometries, can do. Like, let's look at my favorite shape. Gravity creates charge. Yes, let's do it. Let's do it the apple way. The cardioid. Right? Divergence. And then convergence. This would have a positive charge. This would have a negative charge. This is a Janus particle, as they call them. And I suggest that the neutron is the Janus particle, really, because it has everything contained in it in terms of the Janus point. But this is just this geometry will modify the charge because it's asymmetrical. It modifies the charge. It's got an uneven charge distribution on it. And this is the way space-time works. It's like a curve. No, I'm not saying that there's this plasma thing where, like, here's the Earth and the Earth is positive charged, though. Actually, it's the other way around. And this is negative charged. Because what happens is in mass possessed space, I was talking about mass-free space before, that's how you create particles. In a mass, because we were doing quantum, in a larger scale, you have a planet, but now each of these little, like, mass units, all the hydrogen, all the particles, they themselves are little processes of positive and negative charge. So the distribution is not as clean. It's mediated by this charge distribution through material objects, through these little granules of space that we call matter. Protons and neutrons. Protons have a process. Neutrons are contained, and that's why they can't really survive unless they're in a gravitational field. They will fall apart. They fall apart into this charge. When you envelop that, when you close it up and make it one thing, then you have a neutron. You have to shove that electron back down into the nucleus to create a neutron. Otherwise, it falls apart. It breaks open, and now it's an atom of hydrogen. Slowly, things gather. Gravity causes charge. The reason that the EM fields work like that is because they're all like sort of like derivations off of a flow. Right? Gravity is the ultimate flow. It's spinning in 3 dimensions, which means it attracts everything from all different directions by just sitting there. Magnetic field. Actually, it's best to look at electrical field first. Here's a flow, Bernoulli, low pressure. Electrical field flows in toward the wire because this is going at C, and therefore it's got a low pressure. But there's a little bit of chirality because when you have a cross section, here's the wire. You can't actually touch the wire because this has got the flow going through it. So therefore, when you come is on one side or the other. Chirality. I'm going to do an episode about chirality, and chirality is the path of least action. So this has got this chirality where this is sort of over and this is under. And then you leverage the chirality is what creates the magnetic field. That's a super quick summation of all the forces video, I think. But gravity creates charge. Flat space, curved space, divergence, convergence, plus charge, negative charge, electron, proton. Peace.